Your Academic Skills Center presents this video series to help you strengthen your statistics skills.
Hello stat students, and welcome to the multiple linear regression with dummy coding video presentation. My name is Janine Allwright, and I am the instructional specialist at Walden's Academic Skills Center, where I lead the statistics tutoring team. In this video presentation, we will once again engage with a multiple linear regression. However, this time we have a need for a dummy coding process. Of course, like in any other video in this video series, I will remind you that you are working with a limited sample data set to answer a research question about the greater population. We will add a categorical variable to our multiple linear regression that requires dummy coding, and I will explain the why and the how of that dummy coding process. I will show multiple examples of dummy coding in SPSS, and I will run a full MLR with dummy variables included. I will interpret the results at model and variable level, and I will be sure to tell the full story of the data. Now let's get started. As you know by now, we use inferential statistics to make that connection between our sample and our population to answer that research question that pertains to the greater population. And for the purpose of this video presentation, we will work with a multiple linear regression with dummy coding included. In an earlier video in this series, we built a multiple linear regression model with two independent variables that were both scale to predict a dependent variable also of a scale nature. I'm now going to add a third variable on the independent side that is categorical in nature, and that poses a problem for SPSS. SPSS is not able to handle that variable in its setup, and it requires a technical procedure to change that variable's nature so that SPSS can handle that. And that is the reason why we have to dummy code. Now, dummy coding is very specific. We have to examine the levels first of that categorical variable and run a quick descriptives so that we know what the levels are in that variable and how we are going to proceed to dummy code this. We will need to assign a reference category because there's only one way to dummy code, and that is the correct way. It's called the K-1 method. In essence, I am always going to have one less dummy variables than I had levels in my original categorical variable. In my experience, assigning a reference category to make sure that you're applying the right method, the K-1 method, can work confusing. So I'm going to move it over to SPSS to show you a first example of a dummy coding process. And I'm bringing up a data set that I used for the previous MLR video. I'm trying to predict the number of publications in higher ed based on grant funding and committee work. And I'm going to dummy code the gender variable because I want to enter it in the multiple linear regression. This is a nominal variable and it has two levels. One is male and two is female. This will result in K-1. 2 minus 1 equals 1 new dummy variable that I will create. I have to assign a reference category, and usually the choice for a reference category can be driven by what you are trying to say here. If you are trying to show a result in light of a male interpretation or in light of a female interpretation, that can drive your choice for a reference category, but I have no such requirement here for this presentation, and literature tells us that in that case I will have the reference category decided by group size. And for that purpose, I'm going to run a quick analysis on our gender variable, descriptive statistics, frequencies. I'm going to bring my gender variable over, and I'm just going to run a quick frequency table display that shows me that the male group is the largest group. With the male group identified as the reference category, I will now create one dummy variable and only one for the female group. And to that end, I'm going to use the transform function here, use recode into different variables. Please do not use recode into same variables because you will overwrite that original categorical variable, and it's always best to keep these variables intact. Recode into different variables. I'm going to bring my gender variable over, and I'm going to name my new dummy coded variable female, and I'll give it the same label. I have to click change, otherwise it will not take. Now that I've decided that the male group is going to be my reference category, I can enter the old values for that female part of my variable. The old value for my female part of that original categorical variable was 2. In my new dummy variable, that value will be 1. I'm flushing out that female group and I'm giving it its own group in a new variable. It will be 1, and everything that is not female, all other values, will be deemed 0. Click add, otherwise it doesn't take. And now I have a brand new dummy variable with 2 levels. Either you're in and you're female and you receive a 1, or you're not and you're else and you receive a 0. This 0 and 1 distinction is the exact nature of every dummy variable. I'm going to click continue here, and I'm going to click OK to create that variable now. SPSS lets me know that I did that, but I want to check that variable real quick to make sure that it's set up correctly. And I can see now that I have a new variable called female. It has a label called female, but I want to add the values here to make sure I have all the information I need. These females are annotated with the number 1 and they get the label female. And if you are not female, you get a 0 and you are else. That completes that dummy coding process. And to take it back to our PowerPoint presentation, you can now see in an illustration here what happened when I coded that. I ran a descriptive statistics to learn that the male group was the largest group in my original categorical variable. I am not going to create a dummy variable for male, but I'm only going to create a dummy variable where I'm going to have a 1 and a 0 for that new female dummy variable. In essence, I've evaluated this group size and I selected the reference category to be male. That reference category does not receive a new variable, but the female one does, and that is my new dummy variable. And that concludes the dummy coding process here for this gender variable that had only 2 levels. But not all categorical variables have only 2 levels, and it becomes a little bit more complicated when you add more levels. But I would like to show you an example of what that dummy coding process looks like if you want to engage with a categorical variable with more levels. And to that end, I have a great variable here. It's called regions. This is a variable that has 4 groups. Group number 1 is west, 2 is east, 3 is south, and 4 is north. The first step I have to take here for this dummy coding process is to figure out my reference category. And for that purpose, I would like to know what my group sizes are in that variable. So I'm going to bring the regions variable over into a frequency descriptive statistics function here. Click OK, and this produces the group sizes in that categorical variable. My categorical variable shows that the West group, group number 1, was the largest group, and that will serve as my reference category. In essence, I'm going to create K minus 1, 4 minus 1, 3 new dummy variables. I'm going to flush out the East group and give that group its own variable, 1 if you're in, 0 if you're not. I'm going to create another dummy variable, south, 1 if you're in, 0 if you're not. And I'm going to flush out the north group and give that its own dummy variable, 1 if you're in, 0 if you're not. Let's start the dummy coding process. Transform, recode into different variables. I'm bringing my regions variable over, and I'm going to first set up the dummy variable for the east region. Name east, label east. Careful with the name. In SPSS, the name cannot have more than 8 characters. If you want to put more than 8 characters in the name, you'd have to work with underscores. It doesn't matter for the label. Click change to make it stick. Old and new values. In the old categorical variable, my east group was number 2. I'm going to pull that group out and give it its own variable. I'm going to number it with the number 1. If you're east, everything else gets a 0. And here is that dummy code. Set up again, a 0 and a 1. 1 if you're in, 0 if you're out. Click continue, click OK, and do this one more time for the south group. Recode into different variables. I always work with a reset here. I don't want to interfere with the variable that I've already created. So reset, regions. Here comes my south group. Label it south as well. Click change. All the new values. South was group number 3 in my original variable. That group becomes its own variable with a 1. Everybody else who is not in that southern region will receive a 0. Click add, and I'm done. And I have to create one more variable here, and that's the north variable. Transform into different variables. Reset, regions, bring it over. Select just that northern group, north, in the name and north in the label. Click change, old and new values. The number 4 was assigned to the north group in the original variable. That becomes a 1. Click add, and all other values receive a 0, and click add. Check yourself that you click add there, that you have both 1s and 0s here, and that your dummy variable is complete. Click OK. And I can see now here in my syntax that I actually have created these 3 new variables. Let's take a look to see what that looks like on our data set. And here are these 3 new variables. The name is there, the label is there, but I still want to enter the values. In my east variable, everybody who was east, who lived in the eastern part, was assigned a 1. If you are not in that eastern part, you get a 0. Click add, and I'm done. And I'm going to do that for all 3 variables, a 1 when you're south, and a 0 when you're not, when you're else, and that's done. And lastly, for the north part, I'm going to give it a 1 when you're in the north, and a 0 when you are not, else. Click add, and that completes the dummy coding process for this variable. Let's quickly review what that looks like on our PowerPoint. Here is that original variable. Those are the regions in Africa. I assessed that the western region was the largest region, and that is not going to be coded, hence that black area. East received a 1. In that east dummy variable, everything else was 0. South received a 1. In the south variable, everything else was 0. And north received a 1 in the north variable, and everything else was 0. To summarize, I reviewed how many number of variables I needed. I needed k-1, 4-1 leaves 3 new dummy variables. I selected the reference category based on the largest group, which was West. I did not code that West group, but I coded 3 other variables, and I created 3 new dummy variables. Let's take a moment to review the dummy coding process. We dummy coded because we had a categorical variable that we hoped to enter in the multiple linear regression, but in its current state, it cannot be entered. First, we reviewed the descriptive statistics of that categorical variable and examined the levels, and we determined which level would feature as the reference category. In our case, we chose the largest group as the reference category that did not receive a dummy variable. That resulted in the K-1 method where we created one less dummy variables than we had levels. I want to caution you to dummy code with care because oftentimes when we work with real data sets, we might have missing values. And that makes the dummy coding process a bit more tedious to make sure that we do not accidentally add missing values to groups where those participants didn't ask to be added to a specific group. And let me illustrate that with an example in SPSS. This is a different data set, but surely that must look familiar to you if you have viewed other videos in this series. This is the CDC Behavioral Risk Factor Surveillance System. It's generated with a phone survey, and I can see that the missing values column here has been activated and that there are some missing values where participants chose not to share information. This variable measures marital status and it has 4 groups. Group number 1 is the couple group, married or unmarried. Group number 2, divorced or separated. 3 is widowed and 4 is never married. I already ran the descriptives for this variable and here it is. And we can see that the couple level here is the largest level and I will assign that as my reference category. So I would have to create 3 new dummy variables to represent divorced or separated, widowed, and never married. But I'm dealing with 9 missing values, indicating that 9 participants did not share their marital status. I want to dummy code that with care, step by step, to make sure that I do not accidentally place these 9 people in one of the 0 groups. And let me show you what that looks like. I'm going to click Transform, recode into different variables. I'm not going to code group 1 because group 1 is the reference category. I'm going to find my marital status variable, bring it over. The first variable I'm going to create here is the divorced and separated. I'm just going to abbreviate that here in the name, divorced or separated. Click Change to make it stick. All the new values. In the old variable, this group had number 2 assigned to it, and it will of course receive a 1 in the new variable. Because I have missing values, I cannot use the all other values assigned with a 0 for this example because that would exactly incorporate those 9 missing participants' answers. So I'm going to code this line by line. Group number 1 becomes a 0. Group number 3 receives a 0. And group number 4 receives a 0. You can see now that I've went through every group to assign those zeros and I didn't just summarize it with all other values. Again, I don't want to add these 9 missing values into any of these groups. Alternatively, I could have also used the range option here. Let me remove these numbers here and do this again. So in the group number 1, of course, that is the reference category, it receives a 0. And I can grab these other 2 levels. It's a range. Group number 3 through 4 receives a 0. And again, I've now avoided that I'm accidentally sweeping up these 9 missing values. So do dummy code with care. And that concludes the dummy coding process for us here, but I still want to stay in SPSS and show you a couple of examples for a multiple linear regression where we incorporate these newly created dummy variables so that we can learn how to properly interpret them. And to that end, I'm going to take you back to the PowerPoint presentation where I will share a research question with you that I've actually used in an earlier video in the series, but that I've now built upon with the additional variable, the gender variable. That is our categorical variable that we dummy coded earlier. You can see here that I have 3 independent variables in this research question: grant funding, committee work, and gender. I'm asking to what extent the combination of those 3 variables affect the number of publications. That research question has been translated in a null hypothesis and an alternative hypothesis, and of course it is the null hypothesis that I will be testing in SPSS. Before I move over to SPSS to set up the multiple linear regression with you, I want to make 2 quick comments here. First of all, it was my choice to add 3 independent variables in this multiple linear regression. You can argue that you could easily just use 1 scale independent variable and then add your categorical independent variable as well and regress them on the dependent variable that is scale. I chose to use 2 independent variables at the start because to me that makes a multiple linear regression, and I'm then adding that 3rd categorical variable to it. If you are reviewing this video for classroom or classwork purposes, I recommend that you check in with your professor to learn how your professor likes to see the setup of this research question and this dummy coding exercise. My second comment here is that I hope that you noticed that I left that categorical variable intact. Please do not add dummy variables in the research question or hypotheses. The categorical variable is kept intact for the research question purpose. Just because I had to push that categorical variable through a technical procedure in SPSS does not matter to the research question. It's perfectly okay to have a combination of scale and categorical variables in research questions and hypotheses. And with that, let's get started with the setup of the test in SPSS. And here is the data set that I will be using to answer this research question. My dependent variable, number of publications, 2 independent variables that are scale, grant funding, and committee work. And here's my categorical variable, but I will enter it as the dummy coded variable here, female, because male was the reference category. Let me set up the regression, click Analyze, Regression, Linear, bring the dependent variable over. The 2 scale independent variables will be brought over as well, and I'm placing my female dummy variable below. It's up to you how you rank and order these variables. I like to work with the straight up scale variables first because I will interpret those first, and the dummy variables after because that will be the last part of my interpretation. I'm going to click on Statistics, ask for descriptives, click Continue, and OK. And I now have the output. I'm going to start with a description of the variables to share with the reader how these variables act. Here in that sample data set, I have the mean, standard deviation, and sample size of my number of publication, grant funding, and committee work. But you cannot interpret these values for your dummy variable here. It has no value to deliver a mean for a categorical variable. Keep in mind, it's still categorical. And I'm going to reach back here because remember that variable was left intact in the research question, and in its intact state, in its categorical state, that's how you will describe it here. I have 2 groups in that variable. Male was 64, female was 60. And at this moment, you can share with your reader that you did not enter this variable in its original state into the regression equation, but you dummy coded it in the direction of the male part of the variable that served as your reference category, and the reason that you chose that is that it was the largest group. You coded this with the k-1 method, resulting in 1 new dummy variable called female. The interpretation of this regression model will follow the same steps that I discussed in an earlier video. Let me bring up that slide again to refresh your memory. Of course, we're going to interpret this at model level first. We're going to look at the correlations to just check if there are healthy relationships between the variables. We're going to evaluate the significance in the ANOVA box to see if the model is significant, and if it is, we will interpret the effect size that is going to be the adjusted R-square. Then we will look a little bit deeper at variable level. Each variable will be evaluated for significance. If it is significant, we will interpret the unstandardized betas, including for the dummy variable. And then we will evaluate the standardized betas to see which variable has a stronger push on that dependent variable. And we can see here that the independent variables have healthy relationships with the dependent variable, as the p-values are all smaller than 0.05, and that is great. I also noticed some insignificant relationship between the independent variables, which is also great, but I noticed one variable here that is significantly related with committee work, and that is our gender variable. I'm still calling this gender because it's the stand-in for our categorical gender variable. Let's move to our model interpretation here. This regression model is definitely significant with a rather healthy adjusted R-square. 17.5% of the variance of our number of publications can be predicted with the combination of the three independent variables: grant funding, committee work, and gender. And now that I've completed the interpretation at model level, I can dig a little deeper into the interpretation at variable level. And I can see here that grant funding indeed is a significant predictor. Unfortunately, committee work is not. It has a p-value greater than 0.05, so it will drop off. I will not further interpret a variable that does not show significance, and it will not make a presence in the regression equation either. My gender variable with that female stand-in here is indeed significant. When grant funding increases with 1 unit, in our case that is $10,000, so if I add $10,000 of grant funding, my publications will go up with 1.033. Now the interpretation of the dummy variable here is not just female by itself, but this is female compared to its reference category. I always see that in a visual way. I see a division where I put the name of the variable on top. It's the numerator, and the denominator is the reference category. So females compared to males have 3.225 higher number of publications while holding the other variables constant. If I want to compare my grant funding to my female variable, to my dummy variable, to see which one pushes harder on that dependent variable, I can compare them here at standardized coefficient level with the betas, and I can now confirm that grant funding is indeed a stronger push on that dependent variable because it shows a 0.32 versus a 0.2. It has moved positions. It was ranked differently here, so careful that you do not accidentally interpret variables that use different unit sizes at unstandardized coefficient level, but you want to really only compare them at standardized coefficient level there so that these comparisons truly make sense. That 0.32 is rather important for the social change question because that is where I would focus on first if I wanted to make changes to those number of publications in a motivating way. We didn't just look at one categorical variable here, we also looked at another variable that we dummy coded, and that was regions in the United States. I hope you remember that from earlier in this presentation. And as you can see here, that region variable was assessed for group size, and we determined that the west part, the western region, was the largest group, which led us to create 3 dummy variables, east, south, and north. And I'm going to run another regression here with the exact same variables, but I'm going to swap out that gender variable with the region dummy variables to show you what an interpretation would look like if you have more groups. Click on Analyze, Regression, Linear, the same variables, dependent variable, number of publication, grant and committee work. And now come my 3 dummy variables that I will enter at the same time. I'm going to ask for the descriptive button here. and I'm going to click OK. The interpretation of these regression results will follow the same process. First, I'm going to describe my variables in the sample data set here. Number of publications, mean standard deviation, sample size, grant funding, committee work. As I mentioned earlier, I cannot interpret the means and the standard deviations for these categorical groups here. So I'm going to bring up the frequency table that I created earlier. This is where we decided that West was the largest group, and we created 3 dummy variables. At this moment, you can describe this variable and share with your reader that you had to dummy code this variable, and you decided to dummy code in the direction of the West group. It served as a reference category based on the fact that it was the largest group. By using the k-1 method, you created 3 new dummy variables, east, south, and north. The first part of interpretation here, of course, is the correlation matrix. I can see that all my independent variables have healthy relationships with my dependent variable, but I also see some existing significant relationships between the independent variables. If something goes wrong with this regression, this is the point where I'm going to come back to. Let's interpret this at model level first. I have a significant relationship, so I can reject my null hypothesis. I have a very healthy adjusted R-square, 45.4%. Of my number of publications can be predicted with my grant funding, committee work, and the regions in the United States. And at variable level, I can now see that most of my variables are indeed significant. Except for committee work, it's still insignificant in this regression. Didn't make a difference to add the regions variables in here. Grant funding produced an unstandardized coefficient of 0.578. And my east, south, and north are going to be interpreted here compared to the reference category. Remember, I stated numerator divided by denominator. East compared to west has a 2.974 lower number of publications while holding the other variables constant. South compared to West has 4.462 lower number of publications while holding the other variables constant. And North compared to West has 9.457 number of publications increase. And that is a big number here, and that also drives the standardized coefficient comparison here, because as you can see, that is actually the strongest standardized coefficient, the strongest beta here when we take the unit effect out of it. And that means that if I want to motivate positive social change in order to increase the number of publications in higher ed, I would focus on the regions first. I would probably go look to see what they do so well in the northern region and try to export that to the other regions that are so much lower. And for the last part of this presentation, I'm going to return with you to the PowerPoint to show you the same tables, but I will give you some guidance on which numbers are important for your write-up. Of course, we will describe our variables because we want to share with the reader how these variables act in this sample data set. But as I mentioned before, we can only describe the number of publications, grant funding, and committee work here with the mean and the standard deviation. We cannot describe these dummy variables with means and standard deviations. For that, we will reach back to the original descriptive statistic output for the categorical variable. The region West, East, South, and North can be used to describe the levels of this categorical variable. That will be followed with an interpretation of the correlation. I will have to evaluate the relationships between the independent variables and the dependent variable, and here are those numbers. But I also want to take a look at the independent variables and how they correlate to each other. That could be a red flag moment if something goes wrong with this regression. And after we interpreted the correlations, we can then move to the interpretation at model level. This model is significant, p smaller than 0.001. That is paired with the effect size, adjusted R-square. And of course, you're going to need your degrees of freedom and your F value to write this up in an APA way. The interpretation at variable level always starts with an evaluation of significance. Do evaluate every variable for what it brings to the model. That will be followed with an evaluation of the unstandardized coefficients. And lastly, by the standardized coefficients. We can see here that committee work was not significant, so we will only mention that it dropped off, that it's not a significant variable, but we will not further interpret that. Lastly, we're going to build the regression equation. The numbers for the regression equation truly come from the coefficient box. And I'm not going to add that committee work here in that regression equation. As mentioned earlier, it dropped off for significance, so it will not make an appearance in the regression equation. The constant is 3.879. Everybody starts with a 3.879 number of publications. We add the grant funding to that, multiplied by the unstandardized coefficient. We will then subtract the eastern region, multiplied by 2.974. We will subtract the southern region, multiplied by 4.462. And we will add that most successful region, the northern region, 9.457. And that completes our regression equation and the multiple linear regression with dummy coding presentation.
Thank you for watching this video presentation. If you have course-level statistics questions, reach out to our stats tutors at statsupport@mail.waldenu.edu or view our statistics support resources at academicskills.waldenu.edu.